Okay, this is a video for students to understand the unit circle and evaluating the trig functions sine and cosine using the unit circle. So we call this a unit circle because it is a circle whose radius is 1 unit. So if I have a little measuring tool that I just made here, so the length of that is 1 unit, and so the radius is 1 all the way around here. 1 is a unit, so we call it a unit circle. So because its radius is 1. And this is centered at the point 0, 0, but this is just on the x-axis here, y-axis here. So it's on the x-y plane. And I just noted some other points on those axes. So this, we said, is a length of 1. And in fact, let me darken that a little bit so we can see it. So this is a length of 1. And then I measured another length of 1 and another length of 1. So far, for example, this then would be 3 units long. And let's use this measuring tool to measure around this length here. So let's see. So, and this isn't, curvy, but just use it roughly estimated like there. So that's 1 unit, gets us about there. Another unit gets us there. So that's about a length of 1, a length of 2. About here is about a length of 3. So around there is about a length of 3. And so let me try that one more time. So we had a 1. Let's see. So 1 unit is about here. Another unit is about here. So this is a length of 1, and another one is a length of 2. Another is a length of 3. And if we go to exactly here, the length is 3 and a little bit, 3.14159. So we say this, the length of this little curvy thing is exactly pi. And that's why we say right here, we call this pi because that would be the length of this thing. Since this is a length of 1, if you measure this out, that's 3 and a little bit more. It turns out it's exactly 3.14159.265, etc. It's exactly the length of pi. And so this curve length here is, or arc length is pi. So if we go to just half of it, then the length of this piece here is pi over 2. And if we did only 1/4 of this, so half of this length here, then this length here from there to there is just pi over 4. And then we do 1/4 pi, 2/4 pi, just the same as this. So 2/4 pi. 3/4 pi would get us to here. So we go another little bit. So that's 1, 2, 3/4 pi. Gets us here. 4/4 pi is the same as 1 pi. 5/4 pi gets us here. So double check that. 1/4, 2/4, 3/4, 4/4, 5/4 pi. And so that's the length of this curve. And if we went around to here, that would get us to 6/4 pi. Divided 2 out of top and bottom of that, that's the same as 3/2 pi right here. And again, that's the length of this measure. If we went 1 more 4th pi, so if we go around to here, that's 1, 2, 3, 4/4, 5/4, 6/4, 7/4 pi. And if we went another 4th, we'd get to 8/4 pi, or just also known as 2 pi. So this is also 2 pi, but it's also 0. If we hadn't gone around any, we'd be right there. So that's where this pi thing comes in. And so we can denote different, or we can locate different angles there. Notice also that we say this is a 90-degree angle. So if we're measuring these things, not in terms of the length of this, but in terms of the measure of the angle, then since this angle is a right angle, then this position here is 90 degrees. Go another 90 degrees in rotation, you end up where this is, 180 degrees total, located there for pi, etc. And all the way around the circle is 360 degrees. Very often, though, in this class, we'll refer to the angle we're talking about by the measure, how far around the outside of the circle we are. So that's where that stuff comes from, and that's this little measuring thing, the fact that this measures to be exactly pi. If we measure this curvy upper part of the circle, that's why we say that's pi, pi over 2, etc. And so, let's see. So let's start then with this picture, and we'll note that at this point here, if we rotate around an angle, or sorry, in radian measure, the measure here, and get to pi over 4, we could find the coordinates of that little point on this circle. And so we know here that this radius is 1. This angle here is 45 degrees. This angle here is 45 degrees. And since those are both 45-degree angles, then this length and this length are the same. And so let's draw that little triangle a bit bigger, or at least over here, sort of. So there's that little triangle. The radius is 1 because it's a point on that circle. So this length here is 1. And then we don't know these lengths, but they are the same. I'll just call this A and A. So this distance is A, this distance is A. We can find out the value of A by doing the Pythagorean theorem. So A squared plus this A squared equals this 1 squared. So A squared plus B squared equals C squared. In other words, 2 of these A squareds, 1 and 1 more of them, equals 1. A squared equals, divide both sides by 2, 1/2. And so A equals, it would be plus or minus the square root of 1/2. But since A is a length, we'll leave it as the positive part of it, not plus or minus. So A is the square root of 1 over the square root of 2. A is 1 over the square root of 2. Or if we like to rationalize the bottom, which folks often like to do here, we can multiply top and bottom of this by this number square root of 2. So multiply by square root of 2 over square root of 2. We're really multiplying by 1. We won't change the value of A. Upstairs we get square root of 2, and then square root of 2 times square root of 2 is just plain old 2. And so the length then on each of these sides is exactly square root of 2 over 2. Same for this one, square root of 2 over 2. So, and those lengths correspond to the x coordinate and y coordinate of that point. So it was over the number we computed as square root of 2 over 2, and then up square root of 2 over 2. And these coordinates, let me find a fresh piece of paper. So these coordinates give us the cosine and sine of that angle. So the first coordinate is always the cosine of the angle, cosine of theta. The second coordinate will always be the sine of theta, or whatever angle is. So here we can see from this, redraw that. So again, we found this length around here is exactly pi. And so halfway around, So from here up there, the measure of that would be pi over 2, half of that. So half of that, this measure, pi over 4, is this length. And then we just crunched out the coordinates there. So it was over square root of 2 over 2, and then up square root of 2 over 2. Those are the x and y coordinates. 0, -1, etc. -1, oops, -2, dot, 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 height of 1. So, and those things then give us this first one here is cosine of that angle, cosine of pi over 4. This one, the second coordinate, is the sine of the same angle, sine of pi over 4. And so, for example, if we needed the tangent of pi over 4 or the cotangent, whatever, so for example, the tangent of pi over 4 then is the sine of it over cosine of it. So sine of pi over 4 over cosine of pi over 4. The sine is the second coordinate, square root of 2 over 2. The cosine is the first coordinate, square root of 2 over 2. We have this over itself. Our answer is 1. And so the tangent of pi over 4 is exactly 1. And we can, from the same circle, we can get sines and cosines of other related angles, like the following. So let's suppose we need to find the, for the angle, let's say for the angle, let's try 7/4 pi. Let's first locate that. So we draw our unit circle. So we shouldn't need this thing here with us. We'll just remember that halfway around the circle, the length there is pi. This is talking about fourths of pi. So here's pi over 4 is that measure. Go another pi over 4, we get 2/4 pi. We get here 3/4 pi. Here we get 4/4 pi, 5/4 pi here. So 1, 2, 3, 4, 5/4 pi. 6/4 pi would be here. 6/4 pi, also known as 3/2 pi. And then 7/4 pi here. And that would be 8/4 pi or 2. So 7/4 pi, we go around 7 of these 1/4. So we end up at this point here. Notice the triangle is one that has the same length as this triangle had. So the two shorter sides each have a same length of square root of 2 over 2. And let's see, say this is here, 1, 2. Recall we're on the x and y axes here. 1, go up to 2, and then down -1 and -2, -3, etc. So the coordinates here, we go over, and we know the length of this and this is square root of 2 over 2. Hang on, I'm gonna pause because we have a meower. Oops. Okay, we fed our kitten, so she's not meowing anymore. So we're locating the angle 7/4 pi. So we went over 1, 2, so 1/4 pi, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4 pi right here. So we see the same little circle, this length square root of 2 over 2, this length square root of 2 over 2, except here, yeah, we go over, there's 0, 1, 2, so we go over the first coordinate, square root of 2 over 2, over, but then the next one we go down in the negative direction. So the second coordinate is negative square root of 2 over 2. And again, these are the cosine and the sine of that angle. So the cosine of 7/4 pi is this number, square root of 2 over 2. And do I see my calculator? Oops. Okay, I don't see it here. I believe that's around 0.7 or so, maybe around 0.7. Check on your own calculator. So over about 0.7, which seems right. If that's 1, that's maybe almost 3/4 of the way. And then this one would be down about that much, so not quite -1. And then so sine of 7/4 pi is negative square root of 2 over 2, or in other words, negative around 0.7 perhaps. And then using the sine and cosine, if we needed any other angles, we could get those. So for example, let's suppose we needed the secant of 7/4 pi. So secant of 7/4 pi, secant is the reciprocal of cosine. Cosine was, so it's 1 over cosine of that. 1 over cosine is square root of 2 over 2. So we get 1 dividing by this fraction is the same as if we flip and multiply by the reciprocal. So 2 over square root of 2. We get 2 over square root of 2, which is the correct answer for the cosine. Or if we prefer to write it rationalizing the bottom, we would just multiply top and bottom by the same number, which is square root of 2 over 2 will help us out. And so we get 2 times square root of 2 over square root of 2 times square root of 2 is plain old 2. 2's divide out, and we just get the number square root of 2. So the secant of that thing is this number here. If we needed the cosecant of 7/4 pi, that's the reciprocal of sine. So I just remember it as an S and a C here. So this is the reciprocal of the sine of 7/4 pi. We get 1 over, in this case, the sine was negative, so 1 over negative square root of 2 over 2. So we get 1, and then dividing by this fraction is the same as if we flip and multiply by the reciprocal. 2 over negative square root of 2. We get -2 over square root of 2. And notice that's just the opposite of this, so we just get negative square root of 2. That's the cosecant of that angle. And similarly, if we needed the tangent or anything else, we could figure that stuff out. Let's try the cotangent of 7/4 pi. So cotangent is the reciprocal of tangent, that is cosine over sine. So cosine of 7/4 pi divided by sine of 7/4 pi. Let's see, cosine here was positive, square root of 2 over 2. Sine was the one that was negative, so negative square root of 2 over 2. This divided by itself, except a little minus in there, we get an answer of -1. So that's our cotangent value. And we could really find any of the 6 trig values at that point just by knowing this sort of thing. And then similarly, if we need to evaluate and find out, sine, cosine, tangent, any of those for 5/4 pi, we locate the coordinates here. So that is over negative. So negative, the first coordinate, negative square root of 2 over 2, the cosine, and then down negative square root of 2 over 2. So that's our cosine of 5/4 pi. That one's the sine of 5/4 pi. And then another here, 3/4 pi. We get this little triangle there. And so we just note the coordinates of at that point on the unit circle. So over negative square root of 2 over 2, but then up positive square root of 2 over 2. So that's the cosine and sine of this angle, 3/4 pi. So just notice we use the Pythagorean theorem to find out those lengths, but really after this now, people generally memorize if it's an angle like pi over 4 or one of these different multiples of it. We will have a triangle, and both coordinates here, in other words, the length of this and the length of that, will be the number square root of 2 over 2. So people tend to memorize that. That goes with finding sines and cosines of angles where we have pi over 4 or 3/4 or 5/4 or 7/4 pi, or even negative pi over 4 or negative 1, 2, 3/4 pi, etc. So that's one bit of information that'll help us out when evaluating trig functions there. And another thing to note here is we said that measuring this distance there, since this is a unit of 1, if we measure it along, the length of the outside of this, or the perimeter of this half of the circle, is pi, and halfway up here, pi over 2. And here we split the pi, that half of the upper half of the circle, into 4 equal slices of pizza. If we instead split this upper half of the circle as a part of a pizza into 6 equal slices, let me see if I can do that. So we divide this upper half of the pizza into 6 equal slices, make them as equal looking as you can. So then, since the entire length of this outer curve there is pi, each of these has a length of 1/6 pi. So here, this little angle there, a length of pi over 6. If we go 2 of those, this is 2/6 pi. Or divided 2 out of top and bottom, we get pi over 3. Here we get 1/6, 2/6, 3/6 of pi. So 3/6 of pi, also known as divided 3 out of top and bottom, we just get pi over 2 there. So 1/6, 2/6, 3/6. This would be 4/6 pi right there. Or divided 2 out of top and bottom, we usually call that 2/3 pi. So let's see, 1/6, 2/6, 3/6, 4/6, 5/6 of pi right there. And then this is 6/6 pi, or just plain old pi. And then we would locate 7/6 pi here, and 8/6 pi there. So 8/6 pi. Divided 2 out of top and bottom of that one, and we get 4/3 pi. So that's 7/6, 8/6. This would be 9/6 pi right here. Divided 3 out of top and bottom of that, we get 3/2 pi. So 7/6 pi, 8/6, 9/6, 10/6 would be here. So 10/6 of pi, or divide 2 out of top and bottom, we get 5/3 pi. So that's, let me see, so 8/6, 9/6, 10/6, 11/6 of pi here. Make it more like that. 11/6 pi. And then all the way around here would be 12/6 pi. So 12/6 pi, which is also known as 2 pi. Or this position is also known as 0, because if we hadn't rotated around at all, we'd be here. Or if we rotated around 2 pi, we'd also end up at that spot there. So, so the other key angles that folks often know by heart, they're the sine and cosine at each of those angles, are these things that are some kind of multiples of pi over 6. So, and so I'll start on a fresh circle, but that's how we locate those things there. So Again, if we measure this length here, it's a length of pi. If that's a length of 1, that's around 3.14, whatever, pi. And so, like we said, if you split it into six equal slices upstairs, 1, 2, 3, 4, 5, 6, pretty close anyway. So here's pi over 6. For example, let's draw the little right triangle there and try to figure out the coordinates at this point, because those again will give us the cosine of pi over 6 for the first coordinate, and then the sine of pi over 6 for the next one. So, and this won't be an exact proof, but we can try to estimate this height here. Looks like it'd be about a half. And this isn't proving it, but this side ends up equaling a half. And so we ask ourselves, would that be the x coordinate or the y coordinate that is a half? And it is the y coordinate. Looks like a half here. So over something up a half. So the sine of pi over 6 is a half. Sine of pi over 6 is 1/2. To find out the other coordinate, which will tell us this other piece, the cosine, we'll say we don't know what that is. Let's call it running out of terms. How about we'll call it p, and then we'll figure out what that is. So grabbing our little circle here, you're okay. So we know this radius is 1 because that's the radius of the circle. So this length of the hypotenuse is 1. We'll believe for now that this height is a half. It looks like about half of that. So this distance here will be a half. And then we don't know this missing side. I'm calling it just p to give it a name. But we can find the value of p by doing the Pythagorean theorem. A squared plus b squared equals c squared. So p squared plus parentheses a half squared equals the hypotenuse squared, 1 squared. P squared plus half times a half is 1/4 equals 1 times 1 is 1. So p squared equals, subtract 1/4 from both sides. We get 4/4, take away 1/4, we get 3/4. And so p would be plus or minus the square root of this, square root of 3/4. But because p is a length here, we'll take it to be the positive square root. So we get square root of 3 divided by square root of 4. That's the same as square root of 3 over, and the square root of 4 is 2. So this other length then, when one length is, or one of the sides of the triangle has a length half, the other one's length will be square root of 3 over 2. And that's like around 0.85, 0.86, something like that. A bit less than 1. It's bigger than square root of 2 over 2. So cosine of that then is square root of 3 over 2. So the sine of pi over 6 is a half, and then the cosine is the first coordinate. Cosine of pi over 6 is this number here, square root of 3 over 2. And so again, usually people do not go through crunching this out each time. We simply memorize that for angles like this, the shorter side has a length of half, the longer side has a length of square root of 3 over 2. So if you crunch that out, I think that's around maybe 0.85 or 0.86, just roughly. We can use that to find sines and cosines at any of these other angles here. So let's say, for example, suppose we want to find the, sine and cosine at the angle of let's say 2/3 pi. So we'll first locate that angle all the way around the upper half. That's got a length of pi. 2/3 of pi would be, if we take that upper half of pizza and split it into 3 equal pieces. I'm going to split it into 6 equal pieces. That somehow seems easier. So 1, 2, 3 equal pieces, 4, 5, 6. So like we said, this would be 1/6 pi, 2/6 pi, also known as pi over 3. 3/6 pi. Here's 4/6 pi, also known as 2/3 pi. And 5/6 pi and 6/6 pi. So right here, that would be 1/3 of pi, another third of pi, and another third of pi. So right here is where we locate the angle in radian measure, 2/3 pi. And we notice that this triangle is the same as, or is the same size really, and got the same side lengths as this triangle here. It's sort of tipped on its side though. We'll crunch out the coordinates there and know that they are the cosine and sine of that angle. So in this case, we look at the first coordinate and the second coordinate. And of these two things, is it this length on the x-axis or this length on the y-axis that looks like it's closer to half? This one here, or about there, that looks like way more than half. This does look like it could be about half, and that's like the x-coordinate. So we'll put a half here, square root of 3 over 2 there. So a half and square root of 3 over 2, except here we are at 0 and we're moving on the negative side. So we get really negative half, but up, so positive this. And then those give us our cosine of the angle. So cosine of 2/3 pi is the answer, negative a half. And then this one here, the sine of parentheses 2/3 pi is positive square root of 3 over 2. And similarly, along any angle around here, we'd have the same kinds of things. So for example, suppose we want to find the, let's find the tangent of, let's do, let me see, what would this be? So 1/3, let's do the tangent of 7/6 pi. So for the tangent of 7/6 pi, I just like to draw a fresh circle each time. Makes it a little cleaner. So that'd be, all of this is 1 pi. So each of these is 6, 1/6, 2/6, 3/6 pi, 4/6, 5/6. Here's 6/6 pi. And then if we split this up around here, we get 1, 2, 3, 4, 5, 6, 6, and 7/6 pi. So 7/6 pi here. It's important to draw it relatively accurately so you can tell which side of the triangle has a length of half and which side has the longer length, square root of 3 over 2. So if we locate the numbers here, it looks like this length, this shorter length here is a half. And then this length here is square root of 3 over 2. So the coordinates are over square root of 3 over 2. So that means we have minus square root of 3 over 2. And then down, so negative half. And here's our cosine. So that's cosine of 7/6 pi is this number. And this number here, the sine of 7/6 pi. And here we're asked to find the tangent of that thing. Tangent is just sine over cosine. So tangent of pi over 6 is sine of that over cosine of that. So sine of 7, 6 pi, cosine of 7, 6 pi. Oops. And so we get the sine, which is negative half upstairs. Cosine is this number, negative square root of 3 over 2. That's a correct answer. You could simplify it though. Let's see what we do. Rewrite the top. Dividing by this fraction is like if we flip and multiply by its reciprocal. So times 2 over negative square root of 3. 2 divided by 2 cancels out. Negative divided by negative cancels out. We get positive 1 over square root of 3. So that's a correct answer. Or if you'd like to rationalize the bottom, which people often do, you can multiply this by square root of 3 over square root of 3. We get square root of 3 over square root of 3 times square root of 3 is plain old 3. So here's our tangent. That's the number that is the tangent of 7, 6 pi. The cotan of it would be if we just flip those and so on. And let's see, so that's a large part of what we need when we talk about the unit, using the unit circle to evaluate trig functions. And now one other little thing. If you are bored, you can stop here. If you want to see where we come up with the graph of sine and cosine, this is where it happens. So let's plot some points on the graph of let's say f of x equals the sine of x. So angles we can plug in are, angles that we can locate on the unit circle. So 0, if we go around 0, we could go around pi over 6. And then 2/3 pi would be right here. Or an in-between spot would be pi over 4, if we like. So pi over 4. Sorry, this should be 1/3 pi, or pi over 3. So this is pi over 6. So 1/6 pi, 2/6 pi, or in other words, pi over 3. And then we have pi over 2. And then I'm just going to put, let's just put 1/4, 2/4. Let's put 3/4 pi here. We'd have some other angles if we wanted, but maybe this is enough. And then the 4/4 pi, in other words, just pi, come here to 3/4, 4/4, 5/4 pi here. And then 3/2 pi there, also known as 6/4. And then let's do 7/4 pi here. And then 2 pi right there. So we'll just find some, plug in some x values and find some output values or y values for the sine function. So, so at each of these things, we'll just be grabbing the second coordinate. So we look at the angle here. Blank piece of paper. There we go. So looking at the angle 0, we can find the coordinates of this point. It is over 1 and up and down 0. So there's the cosine of the angle 0, and there's the sine of the angle 0. So the sine of 0, if the input is 0, its sine, the second coordinate there is just 0. Here, if we look at the coordinates of this point, or at this point here, was over square root of 3 over 2, and up a half. That's the one that looks like a half there. The second one is the sine of the input pi over 6. So when the input is pi over 6, the output is half. when our input is pi over 4, that's the one where we had both sides of the triangle, this and this, both legs of it had the same length. And so at pi over 4, the coordinates were over square root of 2 over 2 and up square root of 2 over 2. We have those kind of memorized. The second one is the sine of pi over 4. So at the input of pi over 4, the output is this number, square root of 2 over 2. And I'm going to say it's around 0.7. So this is 0.5. That's 0. Pi over 3, that's here. There's another triangle looking like the one for pi over 6, except for this one, looks like this side has a length of a half, so over a half, and up, the longer side then is square root of 3 over 2. Which one is the sine value? It's cosine sine. So this second thing is the sine of pi over 3. So the sine for the input pi over 3, its sine is the number, square root of 3 over 2. And I think that's around maybe 0.85 or 0.86 or something like that. Next, if we find the coordinates here, and I'm going to switch to a new picture. This is a little bit less messy, or less full anyway. So for the input pi over 2, we'll find the coordinates at that point. And looks like if we glance at our x and y axes, we're going over 0 and then up 1. So we know the cosine of pi over 2 is the number 0. And then from this one, the sine of pi over 2, that answer is the number 1. So we get a 1 here. And we could plot other points as well. Let's see, pi over 2. We can maybe go here to 1/4, 2/4, 3/4 pi. So 3/4 pi. Let's see, the sine would be positive square root of 2 over 2. And then locating this point here, pi, the coordinates there, over -1 and up and down 0. So the second coordinate is the sine of pi. So for the input of pi, the sine is 0. And we could plug in other inputs as well. So this is probably enough to get us started anyway with the graph of the sine function, and we'll see why it looks the way it does. Okay, so we get our graph ready. We have a rough idea what that sine graph looks like. And I'll just use my same measuring tape here. So we got, that's a length of, or a height of 1. This would be, let's see, 1, 2, 3, a little bit more. So this is, let's say that's pi. And so if that length is pi, we'll connect you over here. Let's extend you. And then, so if you're a length of pi, you can be another length of pi. Hopefully I won't be shifting these right there. So there's a length of 2 pi. Let's tape that together. So if that's the length of pi, then half of it is about here. There's pi over 2. So 1/2 pi, 2 halves, 3 halves pi. Those are roughly right, I guess, close enough. 3 halves pi, 4 halves, here would be 5 halves pi, and 6 halves is 3 pi, so etc. And we could, so here's 0, and then negative pi over 2 is there, and so on. So let's plot the points we do have. on this graph. And actually, if that's up 1, then this is down to -1. So one point we have is over 0 and up 0. So here's that point there. And this is going to be our graph of y equals the sine of x. At pi over 6, well, let's see that if this length is pi, we divide it into 6 equal parts. Let's see, 1, 2, 3, 4, 5, 6. So here's pi over 6. And there's 2/6 of pi, or pi over 3, 3/6. 4/6 would be 2/3 pi. 5/6 is right here, 5/6 pi, and 6/6, etc. So at pi over 6, the height is half. There. We'll do that one in a moment. Pi over 3, our height is around 0.86, so pretty close here maybe. And then at pi over 2, the height is 1. So about here. And then I missed the one at pi over 4, which would be half of this length here. So perhaps there or so. Pi over 4. The height should be around 0.7 or something. And this is 0.86, so maybe about like this. And if we connect those dots, get this kind of a shape. If we plugged in other numbers on the unit circle, so let's see, how about at, let's plug in 3/4 pi. That would be here. Right? Yeah, actually, sorry. Yeah, that's right. Okay, yeah. So so we get 1/4, 2/4, 3/4 pi. So 1/4, 2/4, 3/4 pi is correct. At 3/4 pi, let's see, over up would be square root of 2 over 2, around 0.7. So their height should be around 0.7 here, maybe like that. And at pi, we said the sine answer is 0. So 0 here. And we could fill in more points, but we get a graph that looks roughly like that. Then let's try plugging in an in-between point there. Pi, that'd be 3/4, 4/4, 5/4 pi, 5/4 pi, and 3/2 pi. So 5/4 pi, we have 1, 2, 3, 4, 5/4 pi right here. 5/4 pi. Over and down. The second coordinate, both these lengths are square root of 2 over 2. We go negative square root of 2 over 2, and then down negative square root of 2 over 2. The sine of 5/4 pi. The second coordinate here, it is negative square root of 2 over 2, around negative 0.7 or so. And so if this is a length -1, about like that, we were about here. And at 3/2 pi right here, the coordinates are over 0 and down to -1. This is the sine, and I kind of did it here. And so, and if we continue, we get like that. And now we're at 2 pi. Our up and down sine answer is 0. And then we go 2 pi plus a little bit more. And then we go to, so this be 1/2, 2/2, 3/2 pi, 4/2, 5/2 pi ends us up here again. And so at 5/2 pi, our height on the sine graph is 1. And then we go down like that. And it just continues. And same sort of thing over here. If we tried locating negative pi over 2, let's use this piece. So we check out the angle negative pi over 2. Here's 0, and there's negative pi over 2. Coordinates there are over 0 and down to -1. There's our sine. So the sine of negative pi over 2 is -1, which means we'd be over negative pi over 2 and down to -1. And so we still get this curvy thing. And then it goes like that, etc. And that is why the sine function has this periodic periodicity or whatever. When we get back to 2 pi, we're back at the sort of starting point here. And then we go through the same heights again, the second coordinates there. So here's our graph of sine. If we wanted to get the graph of cosine, we would simply grab, instead of grabbing the second coordinate, we'd grab each first coordinate. And so if we were to do that, and I've already got these listed here. In fact, let me say this graph here is y equals the sine of x. So if we were to grab instead the first coordinates of those points, so at 0, here's the angle 0. Our coordinates are over 1 and up and down 0. The cosine is the first coordinate. So this is the cosine of 0 is 1. So for the input of 0, our cosine height is 1. At pi over 4, the first coordinate is the cosine here. So this is the cosine of pi over 4. So at pi over 4, our height should be square root of 2 over 2, around 0.7. So here, in fact. And then if we sort of zoom off to get to, well, let's do, let's see, so that's 1/626 pi, so 2/6 pi, also known as pi over 3. Get the coordinates there, over a half and up square root of 3 over 2. The first one is the cosine, so the cosine of pi over 3 is this first coordinate here, a half, which means when we plug in the input pi over 3, our height should be 0.5 right there. And then when we get to here, pi over 2, we locate the coordinates over 0 and up 1. And the first of these is the cosine. So cosine of the angle pi over 2 is the first coordinate 0. So over pi over 2, and on the red cosine function, our height is 0. And that's why for the cosine graph, so this one y equals cosine of x. So that, and that is why our cosine graph ends up having that shape. Then if we go, so pi over 2, here's 3/4 pi. I guess the cosine is negative square root of 2 over 2. So negative 0.7, perhaps about here. And then at pi, angle pi, we find the coordinates of this point over -1 and up and down 0. This one is the cosine. So the cosine at pi, that first coordinate, is the number -1. So over pi and down to this -1 here. Like that. And then we see the red cosine graph doing that little curvy shape like this, and plotting more points like that. At 2 pi, we're back here for a height of 1. And then we go down again. And so there's a graph of y equals the cosine of x. And that's where its graph comes from. And that's why at an input of 0, the cosine is 1, etc. So, and this one also continues that way, and so on. So that's where we get our graphs from, and I'll stop our video there. If you made it this far, I praise you very much. Good job.